Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
I have a distinct pleasure to introduce our keynote speaker today. It is a pleasure because I, too, am actually meeting him for the first time, although I've worked with his organization for a while. And they're doing, they're one of the stronger organizations in Microsoft, doing really, really well in terms of all the products that they're selling, which are getting a lot of kudos from the industry as well as, from the market, the customers who are using it. So let me just read his bio for those of you who are not familiar with him. So Kirill Telpinov is a corporate vice president of the Windows and Enterprise Management Division at Microsoft Corporation. He leads the development and marketing efforts of Microsoft Windows management technologies and products, including Microsoft System Center, Systems Management Servers, Microsoft Operations Manager, also known as MOM, and Microsoft's Application Center. Kirill joins Microsoft with more than a decade of experience in systems and network management industry. Most recently, he was the Senior Vice President and Chief Technology Officer for BMC Software. Before that, he was the co-founder, Chief Architect, and Head of Research and Development for Patrol Software Private Limited, originally developer of the Patrol family of products. In January 2002, Computer World named him one of the Business World's 2002 Premier 100 IT leaders. This award honors individuals who have had a positive impact on their organization through the use of technology. Kirill grew up in Moscow, Russia, and holds a master's diploma in systems engineering from Moscow University of Transport Engineering and an MBA from Houston Baptist University. He serves on the board of the U.S. Fund for UNICEF, Texas chapter, whose mission is to help the world's children. He lives in Seattle area with his wife and 2 children. Outside the work, he spends his time skiing and recently was qualified as level 1 ski instructor for Professional Ski Instructors of America. So, of course, there is life beyond Microsoft, which is surprising to me, but good to know anyway that there's a personality which does all the things. So, Kirill, please, right, thank you very much.
Thank you very much. Can you hear me okay? Well, good morning, everyone. It's a distinct pleasure to be here speaking in front of such a esteemed audience. Feels a little scary. It's only reassuring that I have 2 of my wingmen here, Anders and Ashwin, who are 2 architects from my group, who I'm sure are going to help me in case the conversations go deeper than I can cover. Terrific agenda you have here for the next couple of days. I think the highlight is definitely walk down to the waterfalls, and for those adventurous souls of yours who are here, I would certainly recommend sneaking beyond the fence that is down there and walking to the actual waterfall. And you can actually, if you're really adventurous, you can walk behind the waterfall. But I didn't tell you that. Couple more words about myself. I did start my career in Moscow, Russia, some 20 years ago, and as I was thinking about what happened back then, it turns out actually the first commercial product that I ever wrote was a management product, which was kind of surprising because at that time I didn't even think about it, and I also didn't think that pretty much the rest of my career would be spent writing other management products. It was a log analyzer for a Russian-made clone of System 370. And you kind of think about it, you think of mainframe world, and you think that everything was managed and there was no need to create any management products. Well, turns out not true. Turns out even back then, the add-on management technologies were required to make sure that technology actually worked. So, spent quite a bit of time in management industry. I understand this is networking conference, late 80s. I was actually writing network management product for a company called Fibronics that is no longer in business, but at that time they actually had pretty cool technology on the market. Then early 90s, Patrol Software, and then BMC Software with Patrol and a whole bunch of other products. In 2002, in early January, I thought it's time for me to depart from systems management universe, because we, frankly, looking at what happened in the industry back then, we all felt like a failure. Frameworks didn't work, all solutions that were in the marketplace didn't quite perform to the customer expectations. People were spending a ton of money on management technologies, and they weren't delivering to what they needed. So in 2002, I effectively graduated from BMC software with a promise made to myself that I will not work in systems management ever again, and I will not work for big software company again. Well, 6 months after that, I was in Microsoft heading systems management division. So what happened? What happened was Microsoft was calling night and day pretty much from the day I left BMC, and kind of talking about the opportunity that was there. And the opportunity was really to do things right. And the opportunity was to go into that space and approach it from completely different perspective. From perspective that no one else in the industry could effectively tackle the way Microsoft could. And that opportunity, and also opportunity to work with the brightest and smartest in the industry, effectively what drew me to Microsoft, effectively what made my career and my life to a certain degree completely invigorated and restarted here, and made me look at systems management industry from completely different perspective, and put me in a position where we can actually do things right, and we can actually succeed, and we can actually make systems management into something that customers can get satisfied, can get some advantage of, and can help them reduce cost and achieve greater agility. So what is that different that we're doing, and what is behind what we call Dynamic Systems Initiative that we introduced to the world, to the industry approximately 3 years ago, and stayed very persistent executing on this? Well, the most profound change in approach and the biggest difference in the way Microsoft started to look at systems management back 3.5 years ago isn't the fact that you can't really manage unmanageable. If the system, no matter whether it's an app or a piece of hardware, if a system was built as an unmanageable entity without proper instrumentation, without proper controls, without proper model describing how the system is supposed to work, no matter how hard you try, and God, I tried for 15 years, you can't manage the system. You can't come to the system after the fact and attempt to create management solution that would reverse engineer controls that were supposed to be built by people who actually designed the system. So the fundamental approach is that management and manageability needs to be core attribute of the system itself. Just like scalability, just like security, just like any other attribute. And you can't really come after the fact, just like you can't make secure something that was not designed secure. And God, we tried that too, right? Until XP, SP2 shipped, it kind of was very hard to make Windows secure. Until we really started putting secure development process and life cycle in Windows itself. The same here. Unless system is designed to be manageable, unless system is designed for operations, you can't really control it. You can't really reverse engineer that manageability after the fact. And fundamentally, that's why systems management, systems and network management industry really have failed in the last 20 years of its existence. Now, what is that manageability and what form it needs to take? It's really the knowledge. It's really the knowledge in the form of rigorous model of how the system is supposed to function, and what are the controls, and what are the interactions, and what are the different ways the system can be operated is what we're talking about. That knowledge needs to come from the source, and that source is the developer. These are the people who possess the knowledge. These are the people who support the system. These are the people who interact with customers, who run the system on a daily basis. And these are the people who really need to take all of their learnings about intrinsics, about supportability, about customer feedback, and make this knowledge available in a form of model in such a way that people who run the systems and people who use the systems can effectively access this knowledge and make that knowledge useful for their future lives. This diagram is very sketchy kind of view of how the models flow. I hope you can see it from the back. It is it is kind of small, and I apologize for that. But effectively, the model that encapsulates knowledge can come from different sources. Most importantly, it comes from developer, people who build the system. But that model and type of constraints and requirements also comes from administrators and business people and business architects. And those requirements kind of integrated together with actual instrumentation, with actual model of how the system works, come together and flow through this kind of very rough diagram of how the management architecture works. There's some kind of store, we call it configuration management database, and it's obviously federated. You don't want to put one single point of failure in your environment, where all these models come together and get stored. There's always some form of a central manager. There's always some form of remote manager that kind of make this model flow up and down and allow scalability in a very large environment. And then ultimately it gets to the system itself. Effectively, the system itself needs to know how it's supposed to work. And the system itself needs to contain certain local model that defines the working of the system and defines the behavior of that managed environment. And effectively, the job of management is to do a couple of things. It's define of how the system is supposed to look and define and understand what the system is actually doing. And then resolve the differences and make sure that the way it ought to be is exactly the way it is. And make sure that there's a consistency. Make sure that if you define certain constraints, those constraints are met. Make sure that if you define a policy all the way down to your deepest level of implementation, that policy is adhered to and constraints and requirements are met. That's effectively what the whole management and what the whole knowledge-based management is all about, making sure that oughtness and isness are met together, and making sure that there is a consistency between your definition of policy, your definition of constraint, and the actual discovery, the actual topology, the actual behavior of the system. Now, when we talk about DSI, when we talk about Dynamic Systems Initiative, and when we talk about the end goal, we really talk about turning IT and turning systems into self-managed dynamic entities. And there is a lot of selfness here, self-deploying, configuring, adapting, optimizing, protecting, monitoring, diagnosing, healing. And all these things really, again, start with the knowledge that is built into the system. And system itself, that bottom entity that you saw on previous slide, where we talk about kind of the leaf of the environment, the most distinct component, need to be designed in such a way that it can provision itself. Need to be designed in such a way that it can be self-configured and it can resolve the discrepancy between the desired configuration and the actual configuration within the system element, within the system component itself, and so on and so forth, adapting to new requirements, optimizing for performance, protecting from the security point of view, and potentially catching the attacks and vectors right at the system, monitoring, diagnosing, healing. All these things, again, point back to the knowledge that is built inside the system, point back to the model that comes with the system itself. So I talk about the job of the management system and job of the management environment to effectively resolve conflict between oughtness and isness. And it's effectively what the management system does. And it's effectively done in a way that is scalable, that is agile, and that these flows can really connect with each other. And the biggest problem here is staleness of data, to make sure that the data that we actually get from the system is accurate, and the data that the system manifests from itself is something that would really exist there. Latency can be very detrimental to the management here, and if we don't get this accurate data, if we don't get this real-time flow, we can certainly get ourselves in trouble where at the operator level we don't see what's really going on. And to avoid this latency problem, this is really where we put the bottom leaf of the self-manageability, making sure that we really put the intelligence, making sure that we really put the knowledge, making sure that we really put this self-control and self-healing down at the bottom, down at the system level itself. so the system can resolve this conflict. The system can resolve it in such a way that there is no discrepancy, there is no latency, and then essentially propagates the data to central managers, propagate itself to CMDB, and make itself visible at the highest level. But the fact that management needs to be pushed down to the lowest level of granularity, the same fact that systems need to be built to be manageable, and the knowledge about the systems need to exist at the system level itself is hugely important. That's why we're making investments in technologies like WS management. That's why we're making investments in technologies like systems definition model, that are effectively two core pieces, two pinnacle technologies within Dynamic Systems Initiative that will enable us to allow system builders from the lowest chipset, from the smallest chipset to the biggest systems out there, to make sure that the systems are instrumented, the models exist at every level, and the self-managing, self-healing, and self-diagnosing happens every step of the way within the system architecture. So that's really what it's all about, making sure that the management model, making sure that the model that defines the system is built for the lowest level. That's why we work with Cisco, that's why we work with IBM, that's why we work with Intel, that's why we work with many other of our industry partners to make sure that we collectively, as the industry, solve this problem and make sure that we have the model for every system, for every component, for every piece of the environment. Obviously, we're putting models in every Microsoft and Windows system, and our job inside Microsoft is to make sure that we lead by example, by making sure that we define models and we define complete self-managed entities and turn everything that we do into complete self-managed entities, into something that really comes to the world and that's showing how it helps our customers reduce cost of ownership and achieve greater agility. Now, you look at it, you say, okay, fine, this is all nicely said, but it's not really just about technology. It's about people, it's about change of the behavior, and it's about change of mentality. And that is really the hardest part. How do you convince people that they need to build those models at the same time as they build the system, when everybody is driven by time to market, revenue, and so on and so forth? The same reason why manageability was never part of the systems as they were being built. Well, we found a way to do it inside Microsoft. We implemented fairly rigorous process. We call it common engineering criteria, and we make every product built by Microsoft in compliance with that common engineering criteria. All those manageability requirements that I talk about and the need to build models for every system is part of common engineering criteria. So effectively, we're mandating everybody inside Microsoft to build those models at the design phase. We started doing it approximately 3.5 years ago. Just now, we're starting to see benefit. Just now, we're starting to see those models being built in a variety of forms and variety of formats. We're also working on converging those formats so they all become singular and they all become tightly integrated, but the process is working. Now, what we're also starting to see is Microsoft Machine, also working with our partner like Cisco, like Intel, like IBM, create the massive movement in the industry where the whole industry is starting to move in the direction where models and knowledge about manageability is started to be built into the system itself. It's very exciting to see. We're still early. We're still at the beginning of the process, but I'm confident based on what I'm seeing and the shift that I'm observing in the last 3.5 years that we will be successful and we will effectively shift this industry into a more manageable, more controllable state. I mentioned systems definition model, which is effectively a format for us to express the knowledge about the system. At the bottom, I mean, the simplest way to define it, it's an XML. It's an XML-based modeling language. It's a format, a set of constraints. It's effectively a way for us to define information that is pertinent to deploying the system and managing the system. Systems definition model is something that we put on the market back almost 2 years ago when we did design previews with about 150 different companies and partners, large and small. It's the format that went already through 2 iterations. It's the format that we're starting to adopt in all of our products, and when we go through common engineering criteria and when we define our future products, we're now essentially all aligning around what we call SDM version 3. This is also the format that we're planning to publish, working with several of our industry partners, and later this summer you should expect publication of spec of systems definition model, and it is also our intention to make it an industry standard so people can actually take this definition, start implementing it, and we will have one of the existing standard bodies, either DMTF or OASIS or something else, take on the spec and effectively help us move it forward. But most importantly is adoption. And no standard will exist unless it's adoption. And adoption is what we're focused on. Adoption both by Microsoft and adoption by our industry partners. There's obviously commitment from Microsoft to get the model implemented for everything we build and to make this knowledge and to make this manageability baked into our systems. And we're making sure that our partners that work on the spec are also committing themselves to making sure that models in this common format are implemented for every subsystem that they have provided. There's some characteristics that SDM enables us to do. Variety of different models, variety of different approaches. Effectively, most importantly, enabling this model to exist from manageability of the smallest component to manageability of the entire IT organization. So using the same format, you can define your topology, you can define constraints, you can define connections, you can define policy. So the same format can be used by business architect who defines the policy, the behavior, the top-down diagram of the data center. And the same format is used by developer of the smallest component inside the data center. And then it all gets connected by the management system, management environment that is capable of embracing and connecting all those different models. Technologies and products that will fully embrace and fully use systems definition model. I'll spend a few minutes talking about those because these are important technologies that are really proof points that approach does indeed work. Visual Studio 2005 was the first product on the market that introduced systems definition model to our customers, and this is something you can download now and start looking at. This is SDM version 1, so we've obviously made progress since then, and what gets published later this summer is a newer iteration of what we've done there, but it was the first proof point of what happened there. Capacity planning is, I have one friend in the industry who called capacity planning big science. It is indeed complicated and very complicated area where lots of product existed in the market and frankly didn't deliver to what people needed. Capacity planning, classic problem is to predict whether your capacity going to meet your customer demands in a month or so and run those complicated what-if scenarios. What is going to happen if I add 500 users to my installation of Exchange? What's going to happen to my network? What's going to be impact on my servers? What's going to be impact on my storage? Obviously, classic implementation for modeling technology, classic implementation where the model that's defined capacity of the system can help you model the behavior of the system end to end. We put out first version of our capacity planner late last year, and that technology we decided to basically make freely available to our TechNet subscribers, and this is, I assume many of you have access to, and through TechNet and actually through some versions of MSDN, you can get the product and you can see what modeling approach means in the context of capacity planning. Effectively, what we've done here is we defined capacity model for Exchange. We took all the tests that Exchange people were executing and we piped them into the model that defines capacity model of Exchange. And then we basically plugged it into the modeling engine, generic modeling engine that comes with capacity planning product. And now you have technology that enables you to manage Exchange and to monitor and do planning on Exchange end to end with all those things that I defined and described earlier. Admittedly, this is the first version. It doesn't use common modeling technique that we will adopt with SDM. It still needs to go through interaction, but it's an example of how modeling enables you to do capacity planning. Couple of management products that are undergoing major wave of innovations. System Center Operations Manager is next version of our Microsoft Operations Manager, the product that will ship later this year. Starts taking advantage of systems definition model and effectively embeds systems definition model in its interface, enabling administrator to define the service, enabling administrator to define topology of how components need to plug in and how components need to be managed and monitored. Effectively elevating the product from monitoring individual components to monitoring end-to-end service through systems definition model. That's an example of how management technology, how systems definition model gets to market. More interesting example of true desired configuration management through systems definition model is something that we will be delivering to marketplace approximately 12 months from now. You probably heard of or familiar with our flagship management product called Systems Management Server, or SMS. SMS has been on the market for a while. The product has been around over 10 years. And in 12 months, we're going to introduce major new version of SMS, yet again, under System Center brand. And with that new product, we will take systems definition model, and we will allow two things. We will allow people who build components define models explaining and outlining desired configuration or best practice for that component. And then we will enable administrator to connect those desired configurations in the enterprise view, and we will enable administrators to define the model of how those components need to connect and how those components need to work and come together. So that is really the point where all we talk about models and all the benefits of models start to come together. This is for us, it's very important pinnacle point of DSI delivery, where very important critical scenario, if you think about all that's happening in the industry about policy-based, all the things that happen in the industry about compliance, that's where we're going to be able to enable this scenario through Dynamic Systems Initiative and through a systems definition model, where effectively administrator is going to be able to encode the compliance policy and make sure that the systems stay in compliance. Effectively make sure that that oughtness arrow meets with isness arrow, and System Center Configuration Manager sits in between and makes sure that it really stays consistent. I talk about the new rule in Microsoft where everything we build is being built with models. And our next server product, Windows Server, codenamed Longhorn, to be shipped in the second half of 2007, is prime example of that. We're not only making sure that there are manifests and models, health models built for every system component, but we also define configurations of the workloads. One of the major innovations in the next Windows Server that we will put out is ability to make it component-oriented and really ability to configure that server to look just the way you need it to look and configure it just the way it needs to be, so you don't carry all the junk that we traditionally been throwing into Windows Server. So if it's Active Directory, it just has all the necessary components to do domain control functions. If it's web server, it just has all the necessary components for web server, and so on and so forth. And that will be enabled by systems definition model. The models of how those configurations are laid out are actually defined by individual teams who are responsible for those workloads. And as a result, the built-in server manager product that comes with Windows Server Longhorn will enable you to configure and easily reconfigure the server to look just exactly the way you need it, so it's performing more optimally and it is smaller and leaner and easier to administer. A couple of other technologies a couple of other products that's worth mentioning that are very important milestones in the road to delivering Dynamic Systems Initiative. System Center Virtual Machine Manager is something that we announced only last week at the WinHack conference. And that is a new product in our System Center family that will enable you to do very interesting things in managing and administering virtual machines. And that's really the space where we get closer to realizing the dream of dynamic data center, where you can do placement of your virtual workloads, where you can do dynamic movement of your virtual workloads, where you can start addressing issues of patching virtual machines. Really complicated area. And really the area that can only be enabled if those virtual machines, if those virtual images come with the model, come with the full definition of what the workload needs to look like and how that workload needs to be mapped to the physical environment, physical implementation. And last but not least on this long list of innovations is a new product that we announced just last month that will be on the market approximately 12 months ago, currently codenamed System Center Service Desk. And that's effectively the product that will enable us to raise this model-based management approach to the highest level, where you will use modeling technique to define your process, and where you will essentially enable administrator to define this top-down hierarchy, how the systems need to connect, how the workflow needs to work, who has permission to change what, and how this entire IT process ought to function in a complete and closed entity, yet again enabled by model-based approach as part of Dynamic Systems Initiative.
In these things, when you say system or data center, what is the definition of system you use? Is it the Windows Longhorn servers running the service? Is it Longhorn servers and the network running them? Or any other definition? How do you define the system or data center where all these products and these model systems will be applied?
They will be applied top to bottom.
To everything?
To everything.
Okay.
The question was, what do we define as a system? What is the system? Is that a data center or is it just one element? And in our definition, system is both data center at the macro level and a chipset at a micro level. And for us, manageability needs to exist at all of those levels, and all of those components need to be built manageable. So when you design this chipset, we want you to put manageability at the chipset so the chipset can manifest itself and the chipset can tell you whether it's healthy or not. On the other hand, if you're building your data center, we want you to build a model of how the data center needs to look like, and that typically comes from IT architect and business architect, and make sure that at a macro level you also know what is the desired behavior and desired configurations. So as you can see, we're fully embracing the model-based approach in our management family of products from the top to bottom, again enabling IT administrator and business architect to regain control over their environment. And as an example of Windows Server Longhorn, we're putting this manageability straight into individual components, making sure that those components are fully manageable. Now, one interesting scenario that is really demanding, as I mentioned, on the need to be fully model-based, and really a scenario that cannot even function without the approach of design for operations, is a scenario of dynamic workload placement, where you really need to define models for the workload itself and define requirements for the workload. What does it take to run this workload? How does this workload need to be configured? How does that workload interact with other components? And then map it into the definition of the physical environment where workload is to be placed. So you can do this dynamic mapping, and you can do online analysis whether the physical device can actually be applied to running this workload. And without it, the scenarios of server consolidation, availability, on-demand scale-out, job scheduling, and effectively making IT more agile, those scenarios will simply not work. And that is how we're building the System Center Virtual Machine Manager, and this is how we're going to differentiate itself by enabling IT administrator to define virtual workload and define the model of requirements for virtual workload, and making sure that all the computing resources and the storage resources come with the models and can enable System Center to dynamically map them and resolve the differences between oughtness and isness. Another interesting example, and another kind of the area of the deepest need, and the other area where models and working off models as opposed to working off physical environment becomes acutely important, is the fact the fact of how the systems are architected this way. And if you look at the modern hierarchical configuration of hardware, this is certainly not something that we saw 10 years ago. Chassis, blade, motherboards, processors, cores, and God knows what happens underneath cores and what new things are going to be introduced there. This is certainly not the configuration and not the topology that we saw 10 years ago. And that's certainly not going to be the topology that we're going to see 10 years from now. So if we start building systems today that will be hard-coding those topologies in that implementation, we're going to fail 10 years ago, just like we failed with systems management back in the 90s. So effectively, that model-based approach where you define the model of your environment and then you define this lean level of abstraction that maps your model to physical implementation, to that physical topology, that can only work and that can only function and can only be enabled with model-based approach. That's why we're promoting it so hard. That's why we're pushing it out to the industry. That's why we're making sure that our partners embrace this model-based approach and help us drive this industry and navigate it to become more manageable, more controllable entity. Another scenario where model-based approach really enables us to control system better is in alignment between model and policy. And policy, in effect, you can think of policy as a model in of itself. Policy describe how system needs to be managed. Policy effectively describe the oughtness, and then the model describe the system, describe desired configuration, and also describe the isness, describe the way the system looks. And policy applied to models, again, in my view, policy is a model itself, but policy is applied to model and effectively tells the model, tells the configuration of in the model in an abstract form of how the system needs to function. And the simplest scenario here is application of the compliance policy to a group of machines where administrator defines the compliance policy and defines what the systems need to look like, and then that abstraction, that model, gets propagated to the entire system, and the checks and balances start to get performed in every element of the system, whether it's front end, back end, or database, or whatnot in that environment. It is also dynamically configurable and dynamically reacting to change of configurations, where if you define the characteristic of a front-end server, and you define that every front-end server need to look like this, and this is desired configuration of my front-end server, whether you have 1 or 2 or 22, they're all going to look the same. And by deploying this new front-end server, you don't need to go and completely reconfigure and modify your management environment. It gets automatically reconfigured, and the desired configuration, the model of how that system, how that server needs to function, get automatically deployed and lodged in that system, making it more manageable. So the system gets adopted to the new changes, new configurations. And let's say the completely new office gets created and the entire system needs to be implemented yet again. The policy travels with that system. And even though the configuration and the scale is completely different, all the rules would apply, and all the rules of how individual servers and how individual roles in the environment need to look like would be automatically implemented, again, making the environment much more dynamic, making the environment much more agile. So there's couple examples with application policy to models. Yes, please.
I have a question about something you skipped. There's a line that says services, not just groups. I'm just curious to know what the terms mean.
The term service means the actual service that you deliver to the end user, and the group means physical grouping of the machines. So you can define model of the service that you deliver. So you define model defining desired state and desired behavior of your messaging service, for example. And then that would propagate down to the actual physical implementation of group of machines that will realize the server and make it work. So we're kind of debating inside Microsoft what is DSI? Is this management revolution, or is it management evolution? Some of us think that this is very revolutionary, and we're really changing the way systems are built, and we're changing the way management industry function. Some of us say that this is really evolution, and this is really getting back to reality. This is really back to the future, where we're building systems the way they should have been built at the beginning. We're putting manageability into where it belongs. We're putting manageability at the core of systems building. And this is really the most important change, no matter how you call it, revolution, evolution. This is what we're driving. This is what we're promoting. This is the area where we're not going to be able to succeed alone. We really need to work with the industry. We need your help of promoting the idea of manageability at the core of the design, to the scientific community, to all the companies that you come from, that all the companies that you're going to go to, and make sure that we succeed and make sure that we win together. This is a very ambitious plan. When we first announced Dynamic Systems Initiative 3 years ago, we told the industry that it's going to be a 10-year journey, and we're now 3 years into it, and we actually now think that it's not going to be 10-year anymore. We think it's going to be 8, and we think we're pretty much going to be done by 2011, but it's still very ambitious, and we have very exciting 5 years ahead of us of shipping products, of working with the industry, of promoting industry standards and making sure that those industry standards get implemented in both Microsoft and our partner hardware, software, and systems, and making sure that IT administrators get the full benefit of this innovation. But most importantly, we're 100% behind this. This is not just some side initiative that we introduced and kind of keeping on the back burner. This is front of what we're doing for the enterprise. This is front and forward of what we're delivering. This is at the core of every system that we design, and this is at the core of Windows Server System and common engineering criteria. So 5 years from now, the world will look very, very different. The world will be a much better place, and Dynamic Systems Initiative and all the technologies that's going to come as part of it will certainly help us make the IT world a much better place. That's effectively a brief intro that I wanted to give you this morning. I'm happy to stay, answer questions, have discussions. Ashwin and Anders will certainly cover me up on deep technical questions, but please, I open the floor for questions. Thank you.
How do you want to do this? Do you want the mic to go to every speaker, or you just okay?
You can actually hear on the shotgun mic behind you.
Okay. Okay. So go ahead.
Please.
So who is specifying the model? Is for example, if I'm a data center manager, is the data center manager to specify this, or the people who are writing the software specify the model? At what stage do you specify different details of the model?
It's actually both. People who write software define the model of that software in an abstract way. So let's say, for example, I'm the owner of Exchange, and I build Exchange system. So I define generic model of Exchange, and I define what I think is best practice of how Exchange needs to work. And then I ship that model with Exchange environment. Then the owner of the data center, whether it's different titles exist out there, whether it's IT architect or IT administrator, whatever that person called, the person who's actually in charge of putting Exchange and implementing Exchange, that person would take the model that is defined with Exchange, that came with Exchange, and that person would also typically have the model of how that particular data center need to look like, and also what are the exact requirements of that organization, such as message retention policy, mailbox size, desired latency, and so on and so forth, and define the model of that specific data center. And then the tool like System Center, effectively end-to-end management environment, will connect the two, and will make sure that the best practice model that is shipped with Exchange meets the requirements and desired policy and compliance rules of that specific data center, and two will function together.
It wasn't clear to me from the talk that why this model would be generic, because Cisco is going to produce a router and they're going to have their model. Juniper is going to come out with a router, they're going to have their model. Well, even Cisco, they're going to have a model for CRS 5000, and next they're going to produce CRS 7000, which is going to have its own model. And so now I end up with a management plane or a management system which needs to account for all these models. Do you have any thoughts on that?
Yeah, go ahead, Ashwin.
Yeah, actually we're working with exactly this problem. And the way we do that is models could have, it's like a class structure where you can have a high-level class called router, from which you may choose to subclass, okay, only if you need it, okay, only if they are very weird. But even then, a whole bunch of policies can be applied at a router level, and that will work just fine in most situations. If you want to specialize it, yes, you will have to have specialized policies or management packs. And then even there, we allow what we call overrides. That means you can have a basic management pack that allows management of routers. On top of it, you can override its behavior or modify its behavior for a specialization.
So I have a follow-up question.
Yeah, but let me kind of add you a little color to that. We started the work in the industry, and we're very early on defining common models. Common model, we will have common model for router, we'll have common model for database, we'll have common model for server. This is not new work. Conceptually, this is what SNMP MIB standardization effort attempted to implement and deliver quite unsuccessfully, unfortunately. So we're effectively going through new direction where we're taking all the learning from the SNMP community, coupling it with the new technology that enables us to implement effectively secure communication, secure exchange of data, higher fidelity, and then enable people to write extensions.
So you're repeating the work of the policy framework working group of the IETF and the desktop management forum? We've been doing this for the last decade?
Effectively, yes.
Okay.
Raising it to a new level and implementing it, driving it through different implementation.
So just to follow up, so I have very limited network management experience, but given that you have much more experience, would you say that, as you suggested, that there's a common router class, would you say that most management tasks would be, I would be able to perform most of my management tasks for my system based on the common model rather than going to the bottom levels of the specifics? Would you say that, do you believe that?
Well, in some cases, well, in all cases, it depends on how good that common model is. And today, if you look at SNMP MIBs, some of the least common denominator tasks you can perform on just the standard router MIB. But this is really common denominator, and it really depends on how strong the implementation is. And in some cases, it's deeper than in the others, and some of those models are stronger than the other. Again, mapping back to the SNMP world, the standard networking MIBs are actually, well, from my point of view, you give me your perspective, are fairly good. And type of management you can do on routers using standard MIBs are okay. It's different when it gets to databases, where a database MIB is frankly quite weak and really can't be exactly used to manage your databases.
I would say that the router MIBs, and I've written a number of them, are pretty good at monitoring routers. The network operators have told us that they're not good for configuring routers.
Let me add one other comment here. If we go away from routers for a moment and talk about Windows, it's reasonable that Microsoft is the authoritative source. And if I make a claim that once the dust is settled, you will be very well able to manage Windows using this approach, that seems like a credible claim. Now, what it means is if you are going to expand this thing successfully outside of Microsoft's own software, engagement with the industry is of course necessary. So when we're talking about managing hardware, the chassis manager that sits in a blade chassis, right? And power and cooling management in a processor and things like that,
we are working with Intel and we're working with AMD and we're working with HP and Dell and these people. Because they are the ones with expertise and they will be doing the modeling, and it is essential that we get them to join. When we're talking about networking, we are working with Cisco and with other players in this area. We're talking about storage, we're talking with those people. So this thing will be successful to the extent we get industry adoption. Right now, we are fairly optimistic about that, but there are no guarantees. But there are a number of elements in here, and we've seen areas where it has been successful. It was successful at one level with the SIMMOG. We were successful just in the last year, I would say, to get most of the industry to step up around WS management, which is the new WS protocol for this thing. There were a few hiccups along the way, but we ended up getting a broad consensus around that. So driving this thing through the industry is a key part of the project. It's not just a technology project. We're optimistic if we are only partially successful, then we will improve things. This is not one of those all or nothing kind of things where either we manage the entire world or the project is a failure. Right? We will improve things as far as we can. Fine.
Okay, if I think about the management problem in the kinds of settings I've been exposed to recently, I did some work with Amazon. They've got tens of thousands of computers. Was just down at one of the very large banks in New York. Their data centers are hundreds growing to small numbers of thousands. Obviously, there's a strong distributed dynamic side of management. So what I'm curious about is how strong the consistency needs are for management information. And let me explain what I mean, and then I'd be interested in your answer at any length you want to go. So you've defined model, policy, and then alluded to notions of system state that's dynamic, and obviously there is the state of the Amazon data center as a whole, and then there's the state of the services. And as you pointed out, you talked about a hierarchy, but you talked about a hardware hierarchy. Similarly, there's a software hierarchy. So I've got the product popularity service, and it has several components because I've scaled it out for one reason or another, and then they may actually have a substrate. So I've got this range of information, and if you think about it, that information is dynamic to varying degrees. The model changes, but not necessarily all that often. But in fact, a place like Amazon is rolling out these services all the time. The state of the individual components flickering like crazy by that standard. It's getting a lot too. Now, those of us who work with data replication like to think about consistency. And there's a range of consistency, the spectrum of consistency properties from what the database guys talk about when copy serializability, where the object acts like it isn't replicated even though it is, but nobody can prove that it wasn't, and that it was replicated. They say, well, here's what I saw, and it's totally consistent with what you saw. All the way down to very weak replication schemes like the peer-to-peer crowd, when they replicate data, you just have some probabilistic guarantee if they even go as far as to give you that. A lot of work on replication doesn't give you any guarantee whatsoever. We over there has done multicast schemes, which are infrastructure, and if you use those to replicate updates, some people might not get them. That's not the role of that layer. So I'm curious to understand where this management problem lives in these two spectrums, and what pieces of infrastructure you're providing in that support, and what pieces you wish you had. It's a long question, but it's so for me is a very large and interesting thing.
You want to try?
Yeah, I'd be happy to discuss that because I spent a lot of time.
It's a long question, and I suspect it's a long discussion.
Yeah, it's a long discussion. We shouldn't do it all right now. But just as a sort of comment, we spent a lot of time on that recently, and it's partly because we have an in-house customer with the same characteristics at MSM. So we are thinking about what happens when you get tens of thousands of machines or hundreds of thousands of machines. And we're learning as we go along. We don't want to claim that we have all of the answers. First, I would say that if you really are geoscale replicating, if many systems are, when you include certainly when you include the client, you have to build a system that survives staleness. If you attempt to manage geoscale by insisting on consistency, it will just break. There was a beautiful story I heard in the early 90s when AOL had their own network, and they had a more than 36-hour outage because they sent out an update to their routers, and the update didn't take in all machines, and now the routers were incompatible, and of course they couldn't roll back the update to the routers because the network was down. So they had to drive out all their routers. And there are people I knew who said, well, why didn't they make that update transactional? But you cannot do geoscale transactional processing over tens of thousands of boxes, maybe thousands of boxes. So I think that you have to build systems that survive latencies. Now, you could make an argument inside a data center that you don't have that kind of situation, but I think that was sort of a short little thing. When you had dozens or hundreds of machines in a data center, you could maybe assume that you had consistency. But once we get to tens of thousands, I think that's a fragile architecture as well. So most of our work is focused on the idea that we accept latency and we learn to live with it. And I think we will get a lot more experience as we engage with people like MZN and Amazon and those kind of.
No,
that's a good answer, except it strikes me that there is a category of apps where the equivalent of leadership elections just are not avoidable. You can't have an air traffic control system with this consistency because of the danger that two controllers think it's safe to route airplanes into the same chunk of the space because the system authoritatively said, I know, and yet there were two different components playing the same role. So there's a spectrum, it seems to me, and it's hard to avoid that. And similarly, I talk a lot now to the CIO of the Air Force. Well, actually, not the CIO, to that office of the Air Force. I used to talk to the CIO of the Air Force, but he got replaced by two components. But his office, anyway. And that there you worry about security policy with very strong implications if it's intra-system. So they also say the same things, but this is just out of whack with the reality that if you're not allowed to access that room anymore, you're just not allowed to access that room anymore. And so
I think my answer would be that there are some. I mean, take the air traffic control thing. That's certainly true, but that's an application level thing. And typically, in most cases, systems management.
The problem is for many reasons.
No, but what I'm saying is systems management. Typically, we try to avoid that kind of dependency. There are certainly apps that require that. Security is a tricky special case. It's sort of in the middle between classical systems management and more application oriented. And I think this would be a good discussion to have. Drill down.
But in security, delays are real life, right? For instance, I go to my desktop and I change my password, and then I go to my laptop. I can use my old password, and it is honored for a while because it understands there is a latency. So, in fact, in most of our approach, we understand this reality. So, for instance, and we provide for it. For instance, a policy for monitoring would go down to a target based on our central information as to that machine got SQL and that machine got Exchange. But when it gets applied locally, it rechecks to see if it truly does have SQL or not, because things could have changed.
Just to say, something Anders said I don't agree with, and that's, I don't think it's the case that you can realistically say, oh, it's the application's problem to deal with these. After all, what would cause the air traffic control system to think it had two primaries? Most likely it's that some management infrastructure restarted the primary because of a transient problem, and the old primary is still there. That's probably an infrastructure issue. So if you pump it up to the app, you're basically saying, we'll make mistakes, the app had better expect that, and we will warn you about it, and then you're on your own to fix those problems. Whereas you could argue that the infrastructure ought to be sufficiently strong that if I want one primary of the transactional database, and it's not just these extreme cases, because your average e-commerce retailer cares about having one transaction server running. So these issues arise all the time. That is actually sort of fundamentally part of management.
But that does depend on the philosophy of how that setup is organized. I mean, it may be that the infrastructure provides an SLA to provide that kind of reliability, or it might be that the application shouldn't expect that kind of reliability. That depends on philosophy.
Yeah, but if you're saying that you're going to implement a specified model, is it reasonable to say, by the way, the model had better only be weakly consistent and has to be tolerant of high levels of asynchrony, and because that's what we do. I mean, actually, I think
That's effectively the model, the way you define it. That
I would argue that we should expect more common things. That 100% availability is not to be assumed in the model.
We have a discussion forum. Let's do that. This seems like an interesting thing. I just want to get a few more questions in if we can.
So this is one of those awkward left-hand, right-hand of Microsoft questions. To what degree do these models integrate with things like InfoCard coming out in Vista? Because that's going to give end users a great deal of network management control in terms of firewall, ports, etc. Have you done that integration internally?
Well, we have a lot of things, and it takes us a little bit of time to make sure that everything is aligned towards the same format.
I know that answer.
And I think I would also say that you will find that we are further along, not necessarily by choice, but we are further along on this alignment on the service side and on the commercial side and on the consumer side. And InfoCard is coming from the consumer stage. We clearly are working on how we're going to integrate that, but we're not very far along now.
Yeah, I have a comment and a question. So in the comment, I think that when you look at something like S&P and router management, you always see that modeling is never complete. That's why we have syslogs. So there's the stuff that we're able to model, and there's the stuff that's on the frontier that's almost like a printf in the code. And we'll live with that. I mean, we can't model everything. That makes it. I guess the question is, the exciting part of what you're doing is you're making very granular information about behavior open and describing it in an open way. So I wonder how open can I run an agent? How do I read that? Just to say it's HTML, just says I speak English. Just tell me how open it is. So are these events going to be registered or web pages?
Yeah.
Okay.
In fact, the approach that we took, and that's the approach that already is on the market, it's not in the format that we talk about. We'll need to go through interaction, but I'll point to Microsoft Operations Manager and the way we provide knowledge into that Microsoft Operations Manager. It's provided in the form of management pack that effectively defines the rules of how the system needs to be discovered, defines the constraints, defines the connections. Right now, it's done in proprietary format. The knowledge that is contained in that management pack is actually published. And technically, our competitors in the management space can take that knowledge and re-implement it in their own product. And that is fundamentally the difference of philosophy between Microsoft and Microsoft competitors in systems management space, where our main priority in systems management is not to collect maximum revenue in systems management space. It's the desire to make sure that our system and our platform is the most manageable, and our systems management technologies play a role in the overall ecosystem. That's why we're absolutely happy and prepared to jeopardize some of the systems management revenue for the sake of consistency or for the sake of platform cost of ownership and agility.
At the high level, the DSI initiative that you described sounds very close to some of the other initiatives that other members in the industry have announced. For example, HP's Utility Computing Initiative, or Sun's N1 initiative, or IBM's Autonomic Computing Initiative. So I was wondering, how would you compare and contrast your initiative with those of other members of the industry, and how you position them against each other, in relationship to each other?
Well, it's a very difficult question. We tend to look at our approach as a more pragmatic one, and we tend to look at our approach as the one that is backed by real implementation, real innovation, and real action. And we tend to look at our approach as something that is being implemented in technology as opposed to being implemented in white papers that then get implemented in custom implementations done by either IBM or HP consultants. And that's really the main difference. The main difference is in philosophy. And I'm sure you saw our advertising that started to hit the screens and magazines called People Ready. This is really what we're about. We're really about empowering the IT pro and giving IT pro tools that simplify their lives and give them all the necessary tooling and infrastructure components to make their life better and easier and make that business people ready. And this is very different from the approach both HP and IBM take, where they really start from consulting. They really start from saying, it is very complex, you can't do it yourself, let us do it for you. And that's effectively where all the roots of adaptive, autonomic, and all the other similar initiatives lead. It's primarily driven by adaptive or autonomic consulting services in those company respective global services organizations.
So I should point out that Asia from IBM.
I'm totally. I have very good discussions with IBM, by the way, and similar conversations with IBM Global Services, who actually agree with this.
So on the slide set, I saw a lot about component configuration and state management. And I wonder whether you have or do anything with behavior management, or whether you view that as the same thing or not. So it's one thing to say, here's how to configure the thing, here is what it thinks its health is. It's another thing to say, this is actually what it's doing. So it's state versus flow. It's sort of transactional stuff. And I wonder whether your models actually try and address that, whether the logging information can try and feed that. Because you can't actually configure around errors, basically.
I'll try to answer that to my best ability. So our models, other than what the relationship of different boxes are and how they're related and how they're constrained, it also speaks about what are the key metrics that need to be measured and in what threshold they should remain. But we can, in our products, we also implement something further so that we can go study over time the behavior of a system or a service and its metrics, and we learn its signature over its business cycle, and we can compare its behavior against that. And then in other spaces, like in the security space, we think about behavior in terms of behavior modeling in terms of security as to what is the usual pattern of accesses made by this user of this application, and if it is deviating from that.
So I guess I would contrast my question from weather reporting to sort of behavioral analysis of this is sort of the general state and this is the workload that's being presented and how well it's doing. That style from a transactional audit style of model. To say, when this person asked this question, this is what actually happened. And whether I can understand the behavior of that component based upon each presented task, each task that's presented to it, and whether it's succeeding with that task or failing.
Okay, yeah, definitely a great question. So, up till maybe for the last few years, we've been struggling with overall health of system and so on. Okay, now that things are getting more stable, okay, availability is reaching 5 nines and so on. People are very, very concerned now about the next level, peeling the onion and looking at the flows going through. And if 3% of my transactions are failing or being delayed or not meeting SLAs, that's of interest too. And we're also investing in there at multiple levels. One is what we call synthetic transactions, which is just keeping the transactions testing. Another one is what we call transaction monitoring, in which we're actually watching the transactions and then giving you an aggregate feel for it. So these are the kind of investments that we'll keep making.
Is that part of the model?
In fact, I was just going to jump in there and say that the key attribute of the whole discussion is that the model is extensible and the solution set is extensible. Meaning Microsoft is not going to do all of this ourselves. That's not our business model. Our business model is to work with partners. So that at this step along the way, somebody may define a new model for how to describe behavior, and then write some tools or solutions that monitor that behavior and take corrective action or do whatever they want to do. What we have done, the aspects of the model that we are right now investing in, and then the corresponding solutions that we're building to leverage that part of the model, are driven by what we understand of our priorities from our customers. And Ashley's product is health monitoring. That's very clearly on the top of that list. Configuration management is also on the top because you can very often trace behavior failures back to config failures. So we are starting at that at the most urgent thing. But at no point is there any kind of lock-in. Right? And we are actively working with partners to get them to join in and bring their expertise and their knowledge to this area. That will never end because there is sort of an unbounded scope of problems.
So at this point, I do want to close this session because we have to start promptly for the next one. And I want to thank you, Carol, for taking the time. So,